Thank you very much, Sahar, and thank you, Evan, for organising this. It's been great to be involved over the past number of months in the group, and now to explain a bit about what we're doing at Ember. And great that Felicia Ruiz and Olia are here. They're many of the people who know a bit about this topic are already involved, so that's really great. So I'm going to talk about coal mine methane from a European regulatory perspective in terms of the new rules that are being proposed in Europe, and that's the core. So yeah, we'll start with an overview of coal before moving on to specifically coal mine methane. I suppose I don't need to give an overview of methane, considering that's what we work on every other week in this group. Then moving on to the main part of the presentation, which is the European Union's new proposal on coal mine methane. And then hope to leave plenty of time for both questions and answers and for your feedback in terms of things like instrument sensitivities that we wouldn't necessarily be experts on, but there would be a lot of expertise in the group on such topics. So overall on coal, and kind of we break it down into coal use for thermal coal for electricity, and then coal use in steel making. And in terms of thermal coal use, it has been rising and it needs to fall sharply. So this graph is from Ember's Global Electricity Review this year, and it shows that this century, coal use for electricity has really risen very strongly, driven by China, and that's the position until now. Last year was also kind of a big rise for coal as the world was coming out of the pandemic. So coal generation rose by 9% last year. But kind of what needs to be done is that coal use for electricity needs to fall by about 13% every year until 13% every year for this decade until 2030. To keep the Paris Agreement's goals still in sight. And then the idea is that in order to be towards net zero emissions, we need to reach net zero by 2040 in thermal coal. So it's certainly a major challenge, but kind of the hope is that kind of last year, Ember's modeling showed that wind and solar contributed 10% of the world's electricity last year. And obviously that's quite concentrated in North America and Western Europe, when that is spread out to other countries and indeed increases in Europe and America, that will enable us to make the cuts we need in thermal electricity, in thermal coal use for electricity. The position is reasonably similar in iron and steel making. So coal use has risen strongly, and kind of the orange line up at the very top shows kind of the efficiency gains which have been made in terms of greenhouse gas emissions per ton of steel. Unfortunately, in steel making, the position, the alternatives at scale. So in electricity, there are wind and solar, very much available at scale, just need to be rolled out more. Whereas in steel making, a lot of the technologies are kind of more early stage and aren't there yet. So why is Ember so? Why do we care so much about coal? I think kind of briefly, we would describe it by saying that the International Energy Agency found that the carbon dioxide emitted from coal combustion was responsible for over 0.3 degrees Celsius of the 1 degree Celsius increase in global average annual surface temperatures since pre-industrial levels. This means that coal is the single largest source of global temperature increase. That's why coal overall is so important. So myself and my colleague Anatoly, we work on the coal mine methane team at Ember. So this is a small schema of what we mean by coal mine methane. So on the left, there is coal bed methane, which we don't really work on. That is kind of purposeful production of gas from coal beds. So that's different. Coal mine methane is kind of methane as a byproduct of coal production. On the left, there is mention of kind of open cut mines, or also known as surface mines. So surface mines are thought to have much less methane than underground mines. And that's probably true overall, but there have been mines where they've been shown to have, similar levels of methane as would be found at an underground mine. So it's generally true that open cut mines have less methane, but in Australia and other places, we've seen methane 30 times more than the usual open cut or surface mine. Then kind of there's underground mines, which is the core issue. The black dots are about kind of pre-drainage. So pre-drainage is basically before mining work actually starts at a mine. The mine is pre-drained, not to necessarily to capture the methane, but because otherwise the methane would be poisonous or cause explosions that would that would harm or kill the people trying to work there. So that's why methane is pre-drained. Then we move on to ventilation air methane. Ventilation air methane is the methane that is pushed out of the mine while actual ongoing mining work is happening. And how this methane, which is typically a handful of percent concentration, how this methane is managed is really core to coal mining methane in terms of it can be utilized, which you see there. Utilization is it's very positive, so the methane is captured and utilized, and that can be utilized for heat or for electricity, either at the mine or at the local grid, depending on if the right regulations are there, which is something that Felicia and her colleagues at the EPA have worked on, have written interesting papers on. Then also the methane can be oxidized. Oxidization is something which is frequently discussed in this group, i.e. turning the methane into something less harmful. And then the third option is that methane can just be vented out, which unfortunately is probably the global norm and is to be really reduced and minimized globally. And then on the right, there is abandoned mine methane. Colin, during the introductions, said that he was going to work on abandoned mine methane project tomorrow. So abandoned mine methane means that even after a mine is closed, that it can still continue seeping out methane for literally decades. And how this is managed is a very important topic, especially as we want to close hundreds of coal mines in the coming decades. So what's the overall size of the coal mine methane problem? The International Energy Agency's latest 2022 methane tracker shows that of the 135 million tons of energy-related methane emissions, 42 million tons are from coal mine methane, 41 million tons are from oil, and 39 million tons are from fossil gas. And so I think this is probably a bit of a bugbear of our team, that often when people are talking about anthropogenic methane, they talk about landfill, agriculture, and oil and gas. The reality is that coal is bigger than oil or gas in terms of its methane. And the 42 million tons figure is probably an underestimate. An average of academic analyses shows that estimates that figure at about 52 million tons per year, which is 25% higher. The reason why that there is such uncertainty is that the base numbers are nationally reported using kind of tier 1 methodologies, which can be 20 years old. So quickly to show what we mean by tier 1 methodologies. Tier 1 methodologies are kind of desk research, maybe a bit of checking the coal deposit several years ago, and then kind of doing ongoing desk research, which is shown to be out by a factor of 2 or 3. Kind of what we would like to see happen, and what would be just a number of percent of uncertainty, would be using these ongoing continuous measurements. So yeah, so China, which is by far the largest emitter of coal mine methane, has not reported its coal mine methane emissions to the UNFCCC since 2014. So that's a major gap in the data. And the size of the problem can even grow in terms of new coal mines currently under development could emit a further 11.3 million tons of methane per year. And for example, there are 169 new mines currently under development in China. So the mitigation challenge on coal mine methane. As mentioned before, both thermal coal and metallurgical coal use has been strongly rising. Wind and solar can displace thermal coal, but unfortunately it's harder in steelmaking, in metallurgical coal. So that's the challenge, but the reason for hope is that identifying and acting on the gassiest mines can yield outsized results. So some recent research from Ember in Australia shows that the 15 gassiest coal mines emit 50% of scope 1 emissions in Australia, and that would echo a lot of the research that the EPA and others have done. So the topic of this presentation is the European Union taking action on energy sector methane, and in our case of what we work on, coal mine methane. So the European Union is not a major emitter of coal mine methane. I think Poland is 8th. Really, China is by far the biggest. So the European Commission, which is the executive body of the European Union, their proposal on energy sector methane was announced in December, and that was 1 month after the Global Methane Pledge at COP26. So the Global Methane Pledge was signed by over 100 countries, promising to reduce their anthropogenic methane by 30% this decade. So it came just after that. The first section that's relevant in the document is regarding monitoring, reporting, and verification. So they've broken it down into underground mines and surface mines. So the text calls for continuous. So continuous is a positive word in terms of that it's not saying you can just check once every month or 3 months, or that's positive. Ventilation, air methane measurement. And then there's this construction of or and. Unfortunately, when the document first came out in December, it said measurement and quantification. But the most recent version that has been leaked through political channels says measurement or quantification. So we're kind of a bit concerned, and we and other NGOs with the same reservation about the oil and gas, the same thing being changed there, have voiced concerns there. So it looks like it might be measurement or quantification, but hopefully that doesn't just mean desk research. And then it says using an instrument with a methane concentration threshold of at least 100 parts per million. So there's another instrument sensitivity mentioned later in the document. And then for surface mines, deposit specific emissions factors, which is pretty typical. That would be seen in Australia as well, because it's harder to do measurement and quantification at a surface mine. Our overall view on MRV is that we think that monitoring methane concentration levels is not really appropriate to characterize methane leaks. We think the relevant unit to monitor methane emissions is the mass of the methane emitted into the atmosphere, and therefore monitoring obligations should build on flow rates and the duration of methane leaks rather than concentration readings. Overall, imposing concentration thresholds may provide an incentive to increase ventilation rates from underground mines, for example, to reduce concentration results, but that wouldn't actually reduce the quantity of methane emitted. It would just be a more diluted form, maybe just underneath the threshold. Secondly, there is the topic of mitigation at underground mines, kind of looking to increase that capture and utilization that I spoke of before. Venting and flaring from drainage stations is to be banned from 2025, except in case, and there are several exceptions. Then secondly, venting through ventilation shafts emitting more than half a ton of methane per kiloton of coal mined, other than from coking coal mines, is to be prohibited from 2027. That's positive, apart from the fact that coking coal mines are exactly the mines that are most relevant. So that's, but there is a separate act proposed on coking coal mines, but it depends on how fast and how effective that other piece of legislation would be. Thirdly is abandoned underground mines, where the EU is talking about making a country by country inventory. Again, there is that backsliding from measurement and quantification now to measurement or quantification. And in terms of the instrument sensitivity, it's installing in mines where operations have ceased in the last 50 years, must be at least 10,000 parts per million, and the equipment must operate for more than 90% of the time involved. So that's briefly what's proposed on underground mine, on abandoned underground mines. And kind of finally, there is the topics of imports and satellites. So NGOs in coal, so ourselves on the coal side, and also NGOs working on oil and gas, are broadly critical of the lack of action by the EU on imports, because obviously the EU imports a large proportion of its fossil fuels from Norway, Russia, North Africa, elsewhere. So the lack of action on imports is worrying, but the European Commission kind of privately counters that they can't just tax non-EU countries so easily. There is such things as international trade rules and laws that can't just disappear overnight. But what is positive is the role of satellites. So the EU promises that a verification role will be attributed to the International Methane Emissions Observatory, which was set up 2 years ago by the EU and the United Nations Environmental Programme and some others. And the idea is that this will set up a methane supply index, which the EU promises will be the instrument used to remove the dirtier producers first as the EU reduces its usage of fossil fuels. So overall, the position on satellites is very optimistic. There have been numerous examples in oil and gas and coal where satellites have found very interesting findings, which have caused companies to have to acknowledge that their methane reporting may be really out of whack. So, for example, some Dutch scientists did some research above a coal mine, a surface metallurgical coal mine in Australia, where the numbers are very divergent. And so that's kind of a reason for hope that the IMO can help to identify where is the worst emitters of methane that are looking to sell their products into the European Union. So that's it from me. We'll be very glad to be in touch on email or anywhere else. And yeah, absolutely, we'd love to take questions or any feedback on our work or the European Union's proposal. Thank you very much.